Today's lesson is on direct variation. If we look at this problem, for speed, the distance a car travels after t hours can be represented by d equals 65t. The table and the graph represent the situation. If we look here at the table, for every 2 hours, we're driving 130 miles. If we look at 3 hours, 195, 4 hours, 260. If we look at the table versus the graph shows the same points. We can just see where it intersects. We want to find the constant rate of change or the slope. Now be careful. When we look at this enlarged, you notice that this at 1, it is not at 50. So we need to utilize our other points to figure out what the unit rate would be, or the constant rate of change, aka the slope. So let's look at 2 points. If we have 195 in 3 hours, how much do we have in 1 hour? Okay, if we divide by 3, we get 65. If we have 130 in 2 hours, we have 65 in 1 hour. So the unit rate, or the constant rate of change, the slope, is 65 over 1. Okay, so 65 miles per hour. When two quantities have a constant ratio, the relationship is called direct variation. The formula looks a little bit like this: y equals kx, where k is the slope or the constant rate of change. For example, the height of the water as a pool is being filled is shown in the graph. Does the graph have a constant rate of change? So is there direct variation? If yes, what would my equation look like? Okay, so let's take a minute and examine the graph. We've got time in minutes and height in inches, and we've got 4 points listed. So if we look at the height over the time, we've got 2 over 5, which is 0.4 over 1. If we look at 4 over 10, and we find the unit rate, it's again 4/10 over 1. 6 over 15 is still 4/10 over 1. And let's just, out of curiosity, let's see what 8 out of 20 is. Again, 4/10 over 1. Okay, so the answer is yes, it does have a constant rate of change. The pool fills about 4/10 of an inch every minute. So if we wanted to write an equation, we're going to start with y equals, and k is the constant rate of change, or our slope. Okay, so we want to use this 4/10, and so it would be 4/10 per minute, or 4/10 times x equals our total. Okay, so here is our equation. Go ahead and write that down. Try this one. The amount of money that Serena earns at her job is shown in the graph. Determine if there's a constant rate of change in dollars per hour. If yes, what would my equation look like? Okay, I want you to pause the video and try this one on your own. In about a minute or so after you're finished, go ahead and unpause the video and then check your answer. All right, I'm going to show you the answer right now. Okay, notice all of my rates and my ratios. $40 for 4 hours, 80 for 8, 120 for 12, 160 for 16. Notice that each and every unit rate is $10 for 1 hour. Okay, so take a look and notice that they're all constant. So the answer is yes, there is a constant rate of change. It's $10 per hour. So what would the equation look like? It would be y equals $10 per hour. Okay, so y equals 10x. Make sure you have this in your notebook written down, maybe even bubble it in as your answer for the equation. Let's look at another one. The equation y equals 10x represents the amount of money June earns for x hours. Identify the constant rate of change. Explain what it represents in the situation. So if we look back at our equation also will tell us what the constant rate of change is. If you're provided with the equation right away, you know that the answer would be 10. So she's going to get paid $10 per hour. So let's try this one. Identify the constant rate of change and explain what it represents. The equation is y equals 55x, and it represents the distance traveled by the Voss family in x hours. Okay, so if they're going 55x, what is the constant rate of change, and explain what it represents. Try this on your own and pause the video. Okay, so let's examine the answer. The constant rate of change is 55, and it represents the miles the Voss family travels per hour, okay? So make sure that you have this written in your notebook. The 55 is the key there. This is always the rate of change, all right? Not all situations have a constant rate of change, and not all linear graphs are a direct variation. For example, if it's not a proportion, when it doesn't pass through the point of origin, and that is not direct variation. There's a $3 delivery charge here that we're accounting for. So therefore, $11 for one pizza, $19 for two pizzas, $27 for three are not all equal ratios, okay? 19 for two pizzas would be how much? It would cost you $9.50 for one pizza, where over here it was $11. $27 for three pizzas, that would cost you, oh, not 8, just kidding. It would actually cost you $9, right? So $11, $9.50, $9 for one pizza. Not all equivalent. Therefore, there is no direct variation. 2 pounds of cheese costs $8.40. Show the cost for 1, 2, 3, and 4 pounds of cheese. Okay, so 2 pounds of cheese cost $8.40. How much for one? Well, if you divide $8.40 by 2, you get $4.20. Now we want to know how much it's going to cost us for $3 and $4. So if we take $4.20 times 3, we get $12.60. Remember on your calculator, if it says 12.6, that's not money. So be careful and make sure that you always have a hundredths place when you're talking about money. Okay, what about 4? For 4, it's $4.20 more than this one. So you could either add it or you could do a proportion. $4.20 for 1. How many for 4? Over x. You could multiply 420 times $4 and you'd get $16.80. Okay, so is there direct variation? Yes, and the constant rate of change is $4.20 because all of the rates are the same. So because all the rates are the same, they directly vary. So the equation would be y equals $4.20 times x. Okay, it's all about the equation. A photographer charges a $30 sitting fee and then $6 for each photograph ordered. Make a table and a graph to show the cost of 1, 2, 3, and 4 photographs. Is there direct variation? Okay, so you're paying $30 for a sitting fee. So if I buy no photos, I'm still paying $30. Okay, and then if I buy one photo, I'm paying $30 plus my $6. If I buy 2 photos, I'm paying another $6. If I'm buying 3 photos, another $6. And I hope you see the pattern here that it's increasing by 6 every time. So finally, 54. Okay, if we would graph this, and we are looking at this 0, okay? For 0, we would be at 30. So if we went up by 20s here, actually, let's go up by 10s. I think that might be a little bit easier to see. Okay, so 10, 20, 30. At 0, we're at 30. Is this representing a proportion? Right away, we can see that the answer is no. For one photo, it's going to be at 36. 2 photos, 42. Okay, it's going to end up forming a straight linear line, but the key here is that $30 sitting fee. Okay, if I buy one picture, money on top, right? I didn't even follow my own directions. Money on top, $36 for one, $42 for 2, $48 for 3. Let's find the unit rates, okay? How much am I paying? $21 for 2. How much am I paying? $24 for 3? No. 20. I got to divide by 3. 48 divided by 3. $16 for 1. So notice that the cost per photo is actually decreasing because that $30 sitting fee is getting divvied up more evenly. Okay, so there is not direct variation. Okay, so you should have in your notebook a few examples and making sure that you have the definitions of the direct variation, making sure that you have this example of a equation in your notes, as well as all the examples that we did here, making sure that you know that the equation is y equals kx. If you do me a big favor and put some stars around this in your notebook, so that way when I come around to check, I can see that. All right, see you next time.